Hello students, in this video we are going to discuss logarithmic differentiation. Now first question is when to apply logarithmic differentiation. So there are two cases to be understood. The first one is f of x raised to g of x. Now what is the meaning of this? Look at the example. See it is something like x raised to tan inverse x or sin x raised to x. Now look at this one. The base is x or function of x, as well as power is x or function of x. Now whenever you face such type of function to differentiate, you have to follow the logarithmic differentiation. By the way, there is one more possibility, and that is whenever you have more than two functions in multiplication or division and you have to differentiate it, then you have to use the logarithmic differentiation. See, in such cases, applying u into v or u upon v is quite complicated. Like example is something like x plus 1 the whole square upon x plus 2 the whole cube into x plus 3 raised to 4. Or it is cube root of 4x minus 1 upon 2x plus 3 into 5 minus 2x the whole square. Now if you observe these functions are quite complicated to differentiate with the help of basic u upon v or u into v rule, and then we are going to use logarithmic differentiation for such functions. Now we are discussing how to apply logarithmic differentiation with the help of some examples. Here is the first one. Differentiate x raised to tan inverse x with respect to x. Now, first of all, I am assuming let y be x raised to tan inverse x. And in next step, we are taking log on both sides. So it becomes log of y is equal to log of x raised to tan inverse x. Now in next step, I am applying one of the property of logarithms, and that was log of m raised to n can be written as n log of m. So according to that property, you can write it as log of y is equal to tan inverse x into log x. This power becomes coefficient. Now we can differentiate this with respect to x, and while differentiating, this right hand side is u into v. So I can write this as 1 upon y dy by dx. Left hand side is log y, derivative of log y is 1 upon y dy by dx. And on right hand side, applying product rule, you can write it as tan inverse x into derivative of log x plus log x into derivative of tan inverse x. Now keeping left hand side same, on right hand side I can write it something like tan inverse x into log x derivative is simply 1 by x plus log x into derivative of tan inverse x is 1 upon 1 plus x square. I have done with the differentiation. What next I have to do is simply get the dy by dx value here, and for that purpose I can write it as dy by dx is equal to, this is tan inverse x upon x plus log x upon 1 plus x square. That is what the right hand side you have, and take y to other side, so y comes in multiplication. Now what is my final answer? It can be written as dy by dx is equal to, we have replaced y by its value, that is x raised to tan inverse x, and this bracket, inside the bracket terms remain same, tan inverse x upon x plus log x upon 1 plus x square. So this is the final answer. Now look at one more example. You have to differentiate sin x raised to x with respect to x. So here let y be sin x raised to x. Taking log on both sides, again we are using same property, that is log of m power n is n log of m, and then this becomes log y is equal to x into log of sin x. And next step we are differentiating this with respect to x, so it becomes u into v on the right hand side. So left hand side's derivative is simply 1 upon y dy by dx, and on the right hand side you can write it as x into derivative of log of sin x plus log of sin x into derivative of x. Keeping left hand side same, now what is x into derivative of log of sin x? Here, because of sin x, you have to apply the chain rule. So it can be written as x into derivative of log of sin x is 1 upon sin x into derivative of sin x plus this is simply log of sin x into 1. Now what next? So I can write this as 1 upon y dy by dx is equal to, see that x upon sin x I'm keeping same, it won't change. Derivative of sin x becomes cos x and log of sin x remains same. I think we have simplified completely. Only we have to write dy by dx, which can be written as y into in bracket x cot x. Now why cot x? Because cos x upon sin x is cot x plus log of sin x. So my final answer in this case is, now y I have replaced by sin x raised to x. So it becomes dy by dx is equal to sin x raised to x into x cot x plus log of sin x. So here we have done with the answer. Now differentiate x plus 1 the whole square upon x plus 2 the whole cube into x plus 3 raised to 4 with respect to x. Now I'm again going for the same step. Let y be the given function. Next step is we are applying log on both sides. Now here while simplifying you need to apply more than one formula of logarithms, and the first formula what comes in mind is log of m by n. Now what is log of m by n? It is log m minus log n. So according to that formula you can write this as log of y is equal to log of x plus 1 the whole square minus log of x plus 2 the whole cube into x plus 3 raised to 4. Now in next step here I am applying formula. Now what formula? If you assume this as say m, this as n, then it becomes log of m into n. What is log of m into n? It is log of m plus log of n. And it becomes then log y is equal to log of x plus 1 the whole square. This much part I kept saying. Minus log of x plus 2 the whole cube plus log of x plus 3 raised to 4. Further we are applying the third formula, which one we used in previous problems also, and that is log of m raised to n is n log of m. According to that, it can be written as log of y is equal to 2 times log of x plus 1 minus 3 times log of x plus 2 minus 4 times log of x plus 3. Now we can simplify such function. So here I am going for simplifying this function. Sorry, here I am going for differentiation of this function. Now differentiating this on both sides, left hand side becomes simply 1 upon y dy by dx, and on right hand side it becomes 2 into derivative of log of x plus 1 minus 3 into derivative of log of x plus 2 minus 4 into derivative of log of x plus 3. Now keeping left hand side same, on right hand side 2 into derivative of log of x plus 1 is 1 upon x plus 1 into derivative of x plus 1. Similarly, this can be written as 3 into 1 upon x plus 2 into derivative of x plus 2. And here it becomes minus 4 into 1 upon x plus 3 into derivative of x plus 3. Everywhere the function is of log only. What next we can do? This can be written as dy by dx is equal to, now this is y I have taken to other side. Now 2 into 1 is 2, 2 upon x plus 1, and what is derivative of this? This is simply 1. This is minus 3 upon x plus 2, and what is derivative of x plus 2? It is simply 1. Minus 4 into 1 upon x plus 3, and derivative of x plus 3 is again 1. Now what is my final answer then? In next step I can write it as dy by dx is equal to, now y to be replaced by its value, that is the original function, so x plus 1 the whole square upon x plus 2 the whole cube into x plus 3 raised to 4 multiplied by 2 upon x plus 1 minus 3 upon x plus 2 minus 4 upon x plus 3. So this is the final answer. Now the next question. Differentiate e raised to x plus x raised to tan x with respect to x. I start with the same step. Let y be e raised to x plus x raised to tan x. Now, the thing is, if you observe, the difference between this problem and previous problem is here you have in the function, basic function only, there are two terms in addition. Well, this was not there in previous problems. Now what to do with such questions then? See, what I am doing is, I am writing let y be u plus v. And if you want to differentiate this, then differentiation will be simply dy by dx is equal to du by dx plus dv by dx. So it is quite simple. Now question is, what is du by dx? What is dv by dx? How to get them? So before writing du by dx, I should define what is u. So let u be e raised to x, the first function over there. And what is du by dx then? It is very simple. Du by dx is simply e raised to x. Because derivative of e raised to x is e raised to x only. Now we are going for the v. V is another function x raised to tan x. Now to differentiate this, we have to take log on both sides. So I can write log v is equal to log of x raised to tan x. Now here I can write log v is tan x into log x. Again, to differentiate this one, I have to apply u into v. So differentiating with respect to x, this can be written as 1 upon v dv by dx is equal to, now applying product rule, I can write tan x into derivative of log x plus log x into derivative of tan x. What next I can write for this? V I am taking to other side, so it becomes dv by dx is equal to v into, in bracket I am writing tan x upon tan x into 1 upon x, that is derivative of log x, and log plus log x into derivative of tan x, that is sec square x. Now let this be equation number 3. So you got dv by dx, du by dx is already obtained, it is in equation number 2. So from 1, 2 and 3, I can say now dy by dx is equal to, now what is du by dx? It is e raised to x. What is dv by dx? This whole term in which v to be replaced by its value, that is x raised to tan x. So it becomes dy by dx is equal to e raised to x plus x raised to tan x. In bracket it becomes tan x upon x plus log of x into sec square x. This is your final answer. Thank you.